This is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about X, Y and Z gradients. That is the coils of MRI. Okay, these are MRI has a gradient coil. In gradient coil, we have X, Y and Z gradients. Okay, in previous videos we have seen about the MR, what are the MRI coils we have and what are the types of coils we have, and in this video we are going to see about what are the three sets of gradient coils, that is X, Y and Z. Okay, if from this diagram we can see that the patient is lying down and we have X coil, Y coil and a Z coil and a trans receiver unit. Okay, trans receiver unit will transmit and will also receive the data which is scanned, right? What is the use of X coil, Y coil and Z coil? Okay, the X coil here, X coil, we can see from the diagram we can see that the X coil scans from right to left. Okay, scans the particular part from right to left position, and whereas the Y coil scans from front to back, and Z coil scans from head to toe. Okay, X coil scans from right to left and Y coil scans from top and bottom, that is patient up and down, and Z coil scans from head to toe. This is the uses of X, Y and Z coil. Next, Shim coil. What is Shim coil? Shim coil is a second type of RF coil. What is Shim coil? Shim coils for homogeneity that provides equal magnetic strength throughout the system. Okay, Shim coil for homogeneity. What is homogeneity? Is thus equality. It will be maintained in the same process, right? That provides equal magnetic strength throughout the system. Okay, Shim coils are used to adjust the homogeneity of a magnetic field by changing the current flow through it. Okay, this Shim coils are used to what is the use of the Shim coil is that it is used to adjust the homogeneity of a magnetic field by changing the current flow through it. By changing the current flow through the Shim coil, the homogeneity of a magnetic field can be adjustable. Okay, this X, Y and Z coil is present in between the Shim coil. Okay, from the diagram we can see that the violet color, right, that violet circle shows the Shim coil, and we have Z, Y and X gradients. These three coils are incorporated into the Shim coil. Okay, Shim coil is generally used to adjust the homogeneity of the magnetic field which is produced in the MRI. Okay, next is RF coils. What is the use of RF coils? Okay, RF coils are responsible for transmitting and receiving the signals. Okay, RF coils are used to, what is the use of RF coil is that RF coils are responsible for transmitting or receiving the signals. These coils are converting the signal into data that gets transferred from computer and processed to form a final image. These RF coils are responsible for transmitting and receiving the signals. These coils convert the signals into data. And the data will be transferred into a computer and it is processed to form as a final image. Okay, that signal will be converted to data, and that data will be seen in the processed and be seen in the computer in the form of a final image. Okay, the quality of MRI images depends on the signal to noise ratio of a acquired signal from a patient. Okay, the signal which is passed from the patient, okay, patient determines the quality of an image. Okay, once we have, if we have a noise in the images which is captured, the image will not be very clear, right? So the signal to noise ratio should be measured to get an accurate MRI images. Hence, the higher signal SNR, that is signal to noise ratio, the better. A low signal to noise ratio generally results in a grainy appearances of an image. When we have the highest signal to noise ratio, the image quality will be very high. Whereas when we have the lower signal to noise ratio, the image will result in a will appear in a gray, or the image will not be very clear. That is the point here. Fine. RF coils, which is generally used to transmit and receive signals, they can convert the signal to data which is processed and shown in the computer for the final image. Okay, for getting a quality image from MRI, the signal to noise ratio to be measured. When we have the highest signal to noise ratio, the quality of image will be very high. And whereas when we have lower signal to noise ratio, the image will have the quality of the image will be very low. Right? Thank you.